So we'll do a couple things with the function and the calculator. We'll do like a max and min, we'll do roots, finding the zeros. Can somebody turn on a couple of those lights back there? Oh, whoever's doing the WebAssign, I still have to remember to go in there and change the dates.
I was going to ask you about that.
Yeah.
Can we just submit for an extension?
Wait a minute.
Yeah, because it was already passed, right? I made it this morning or something. Don't worry, I can go in there and change it, and then it should just globally. So I just got to remember to get in there. Yeah.
So instead of doing it like usually we can do it by WebAssign?
Yes. Yes.
When did I miss this?
I don't know. I think it was in the email I sent before the semester started.
Oh, because since I was an add-on, I didn't.
Ah, okay. That's how I missed.
Add right now.
And it's the same homework. It's exactly the same.
I know, but I thought that the code I was about to throw it away.
The what now?
It came with the book.
Oh,
I
shit.
thought
Well,
you weren't gonna use it.
you can
so.
still use it.
Oh, awesome.
You could just remind me that at some point you went from book to online.
Can I just start all over online?
If you have time. It's a lot to redo. All right, so let's see. Anybody have a specific function they have in mind, or just make something up and see what the hell happens? All right. Let's do negative 4x to the 4th plus 3x to the 3rd plus 6x squared minus, I don't know, 5. Let's see what I've done. Oh, let me go back there so you guys can get it. Neato. Oh, good. So now I see how I want to change it. So negative 4x to the 4th plus 3x cubed plus 6x squared, and then make it, go back. Oh, my calculator's dead. There it goes.
Minus 5, right?
No, sorry. Make it plus 2. Now do me this favor. Anytime you put in a brand new function into your calculator, you should hit Zoom 6. Zoom 6 is Zoom standard. It'll take it back to the 10 by 10 window. So let's see what we can see, if anything. There we go. Kick ass. I have made a nifty looking thing. Say again? Oh, sorry. There's the formula again. Negative 4x4 plus 3x cubed, 6x squared. I just didn't want to have an x term. Plus 2. Now you don't have to do this next thing, but I always do. See how narrow this thing is? And all the interesting stuff is happening like right there. So what do you think I'm going to use? Zoom box. You don't have to, but I recommend it. So zoom box. And if you just move your decimal, move your cursor. I'm going to put way up here so that that'll be a corner of the box. And then when I move it down and over, it captures the whole area that I'm interested in. And go a little bit below the y-axis, the x-axis too. All right. So here seems to be all of the interesting stuff. Kick ass. Okay. Couldn't ask for anything better. And a little word of warning. In some of the homework, I saw details on graphs that there's no way the work you did could have told you about. Like, does the graph go like this, or does it go like that? There's no way. So I want it to be a rough sketch you get purely from the work you've done. When you check it on the calculator, if it's like that or like that connected, you really shouldn't care at this point. In calculus, you can actually calculate, is it going to be like down like that, or is it going to be up and over like that? You can calculate it here. I don't care. If I see that kind of detail, I'm a little worried that it actually was just copied from the calculator, right? You guys semi with me here? So it doesn't have to be perfect, obviously. In fact, if it's too perfect, it makes me worried. So let's first do this. Let's first find the zeros. And of course, how many zeros does this thing have? 2. How many could it have had?
What?
Yeah, it could have had 4 zeros, right? It's got 2 real zeros, and of course, therefore, it has to have. If it has 2 real zeros, it must have 2 complex, just because it's a 4th power. We know it has 4 roots. 2 of them have to be complex because I can only see 2 real. And another side note, where could the other 2 have been? Do you guys remember what I did? The very first thing, didn't I have a -5 first? And then I graphed it, and I saw something that told me I wanted to change it because this whole thing was too far down. It didn't have any roots. So I made it plus whatever the hell I made it. I forget now. So that moved the whole thing up a bit. If I would have moved it up so much, wouldn't this have possibly hit here? Then there would have been 2 more real roots. Because it's too high, now there's 2 complex roots. So I think I told somebody, having some complex roots kind of tells you there's a dip somewhere that if you just move it down a little bit, they would become real roots. How important is that to anything like a test? Not. How important is that to making connections and what the hell's going on? Very. Okay. So how do I find like this root right there? How do I find that 0? Something better than trace.
0.
Yeah, go to second trace, so up to calc 0. This will give you the exact answer. Trace can only get you so close. So go there, hit number 2, or down to it, hit enter. Either way, get to the second thing. And remember, this is going to ask you 3 questions. And of course, my computer has got a lot of stuff going on. So you want to go to the, well, I'm definitely to the left of it now. Okay? I got to be more patient with this thing. All right, so go to the left of it, enter. Go to the right of it, enter. And then get right on top of it, enter. Okay, do you want me to do that again, or are you guys good with that? Let me do it again. One little thing, let me adjust one little thing so this is better, easier to see. I'm going to go to my window and move the whole thing up a little bit so you don't have all these words on top of what I'm doing. I'm going to make my Y max, let's just make it, no Jeff, that won't do it. Make my Y min -8. There we go. So let me do that again. Go to second trace, go to 0. Oh, this is exceptionally slow. So this is what I tell students, because sometimes left and right is a little bit weird. On this one, it's not weird. You go right on top of it, hit the left arrow a few times, enter. Then get right back on top of it, hit the right arrow a couple times, enter. And then your guess, you want to get right on top of it, enter. Can anybody tell me what it's trying to say here?
It's not 0.
Well,
I was gonna ask
it actually
you
is
that.
the opposite. It's trying to say 0 here. It's just that the resolution isn't good enough. So the algorithm it uses to narrow in on this 0 has an error tolerance. It says when you're this close to it, stop. And sometimes the error tolerance, I don't know if I want to get too deep in this, sometimes the error tolerance of when it stops is bigger than the error tolerance for when it says 0 here. I don't know if you guys kind of get me. Whenever you see this, it's trying to say 0. Just like if you saw over here 4.99999, it's trying to say 5. That's what it's trying to say. It just stopped a little bit too early.
So would you want 0 on a test?
Yeah, the important thing is, another thing, why do I know that it's trying to say 0 here for certain?
Because it says 0.
Because I did the 0 of the function, so I know it should be a 0 there, right? So what's one of the zeros of this function?
-1.
-1.067. Cool. And then you do the same thing to find the other 0. Okay, so far so good. You can't do left here, right there, find them both from your calculator. No, it has to do one at a time. Right? If
you put the X into the table, would it come back as 0, or would Y still be that weird number?
If you put this in there, it would probably come up with something a little different there because this, of course, is truncated.
Oh, that's correct.
Yeah. But if you knew the entire thing, it would come out to be that.
Oh.
Because it's not quite. It's probably wrong in like probably around this decimal place.
Sure.
Right? Yeah. Where's the min? There's a local min. Right? I understand there's no real min, but there's a local min right in here somewhere, right? Let's see if the local min is the y-intercept like it looks like. How do I find minimums? Go to, yeah, look. Amazingly enough, you go where it says minimum, and it asks you very similar questions. It says left bound, so you go to the left of what you want, enter. You go to the right of what you want, enter. And then you hit your right on top of it, enter. So again, look here. What's it trying to say here? Oh yeah, exactly. Don't worry. Obviously this is an emulator, so there are slight differences possibly. And it's a TI-84 emulator, so 84 plus. Yeah? No. So there are slight differences between the computer program and the actual calculator. Anybody else have something like this, or do you guys all have 0? E negative 6, something like that. So it's still trying to say 0. Yeah. Because remember, what was my function? Plus 2 here, right? So what's the y-intercept? 2. So certainly, sure enough, that intercept is the minimum. That's kind of neat. Okay, maybe. And to find the max, either one of the maximums, you do the same thing. You hit maximum, left bound, right bound, guess, and it'll give you the maximum. Yeah.
So always the minimum is the y-intercept?
No, definitely not. That's why I was curious if it was. You can never make that assumption. Here it just happens to be. Here it just happens to be also the y-intercept. All I have to do is shift it over a little bit, and it's not suddenly, right? So it's kind of cool that I made one that y-intercept happens to be the minimum. It doesn't have to be.
But if you shift it, like the y-intercept will change to.
Yes, but I'm shifting it left or right. Don't worry. But here it does. It doesn't have to always be. Definitely not. Yeah. Okay. How do you guys feel about those basic graphing things? Okay. Because they definitely could ask you any of those on this test. Oh, there's one more thing. Let me show you something kind of cool. If I wanted to know what f of 1 was, and I really didn't feel like plugging a 1 into the whole function, go to second calc value, the first one, and plug a 1 in, and it'll tell you what the output is. So if you hit second calc value, and you put in there 1 divided by 5, it'll tell you 1/5 goes to 2.25 cents. I mean, of course it should. It's a freaking calculator. You gave it the function. It lives on multiplying and adding, and then subtracting all that other stuff. So it should be able to tell you what the hell is. The one little caveat is you can only use x values that are actually showing up on your screen. So I couldn't do negative 12 right now because negative 12 is not on my screen. Okay, cool. Yeah.
So if you have a function where it's like x to the third or something, and then you have 2 or 3 real roots, then you're
I love it. Exactly. Because there always has to be exactly the degree, that many answers. There might be some repeats, but there must be that many answers. So if you only have 3 real roots for a 5th degree thing, there must be 2 complex roots. Cool. Can you ever have only 2 real roots for a 5th degree thing? What would that imply then? There'd have to be, if there are only 2 real roots for a 5th degree, there'd have to be how many complex? 3. Can I ever have 3 complex answers? They always have to show up in pairs. There you go. So that sounds like a conceptual kind of question I could ask on the test, yes. I won't ask exactly that. Don't get excited. All right, anything else while we got this thing up here that you guys have about the calculator? Okay. Do you guys know how to solve equations using graphing calculator? I think that would pique interest. Like if I had to solve the equation, real quick, I'll just do one example. If I had to solve x squared plus square root of x equals negative 3x plus x to the fourth. Let's see if it's even. Could you do that by hand? The one who said yes, I like you. Where are you? I can do that. I can name that to you in 0 notes, dude. No? Way too old. Name that to me. I was 2 when I was like that. Maybe I was older. Here's how you do this though. Real quick. Because you can use this to check your work. If I ask you to solve an equation, you can use this to check your work. Plug into y1, one side of this bad boy. X squared plus the square root of x. Put your arm down. There you go, Jeff. And then put into y2 the other side. Negative 3x plus x to the fourth. Let's see if I made an equation that actually has any answers. Oh, my scale is all freaky. Oh, it might have an. Oh, yeah, it's got at least one answer. Let me do zoom 6 real quick. It's probably fine where it was, but I just want to see more of it. Yeah, looks good. Look at that thing. How do I know there's at least one answer? Because the answers, of course, would be where they meet. Because I want this graph to equal this graph. You know, so that's all you do. I'm not really sure if there's an answer here because one of them started right around here. So let me, I know, do the infamous zoom box. So it looks like there's a good chance there's a 0 answer, but let's see. See if we can see it. Yeah, it looks like there should be. Cool. Let me move it up a little bit like I did before. Alright, so here's how you find this. So I want to find the intersection. So incredibly enough, just like if I want to find the maximum, use the maximum. So if I want to find the intersection of two things, I use the thing called intersect, number 5. So let's say I want to find this answer up here. Let me see if I can do this. Look at the first question. It says, what's the first curve? Watch what happens when I hit enter. So that's my first curve, right? And this is my second curve, this big belly dude here. With me? So if I hit enter, it bounces to the second dude for me, doesn't it? So now it says, what's the second curve? Well, this is my second curve, so I hit enter. And now it says, what's your guess? So I move to my guess, enter. And so there's one answer to this equation, 1.767, blah, blah, blah. Now the shortcut then, let's find the other one, I'll show you the shortcut. The shortcut is, just move your cursor to the answer from the beginning, and hopefully your cursor moves faster. I have 0 patience, sorry. Just put your cursor up close to the answer. Enter, enter. Oh, I went on the, yeah, it's undefined there, poor little dude. Enter, enter, enter. Let's see if there's an answer there. Yeah. No, I found that one over there. This is really interesting in there. You guys see that though? The thing, we'll investigate that just a little bit more, but you get right on top of the intersection, enter, 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 because it moves to the second curve for you. So the most important thing then is your guess. Get right on top of it, enter, 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 bam. Me, I am really curious.
But you put like totally something different. You don't have 3 of those.
Well, it probably means that there's not an answer down there, right?
Exactly, that's what it means. It found the closest thing to where I was. Remember, the thing that's different between the min and max and this is the min and max asks you for a bound and a bound, so it only searches in there. This asks you for one line and the other line. So it's going to find the nearest intersection to wherever I put my guess. So if we zoom in, really zoom in on this thing there, look. See how that's a little bit up? and that's a little bit down there. So they don't meet. Neato. I wish you could say I did it on purpose, but I certainly did not. Can't see that far ahead. You guys semi with me here? I mean, the important thing to get from this is just how to do these things. Anything else is kind of interesting side notes about the specific problem. They just barely didn't meet there. That's why there was no answer there. Yeah, but what's wrong? What is wrong then? It's strange.
0 plus 0 is 0 plus 0.
It should work. Why is that not? Yeah, 0 should be an answer.
If you look at the table, it says it's at 0, 0.
Yeah, but the other.
Yeah, it should be 0, 0. I don't know why it's freaking out. Yeah, I forgot what I made that. Yeah. Anyway. I'm not sure why it's not able to handle that. It really just doesn't like it there. You think? Oh, I know what it is. So that was an obvious answer, but I think the algorithm this thing uses for this requires it to bounce around a little bit, and there is no side of this one to bounce to.
Maybe when we select the two curves, we select it up. So he's looking for that area, this area.
No, I did. Remember, I put the cursor down here, enter, 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 and it jumped over there. And I think it's because the algorithm it uses needs to be able to go to the other side. But at least that's an obvious answer, thank God.
That makes
0
sense,
works.
'cause you can look at that and tell it's 0.
Exactly. All right. So, great. Oh, you can take a break whenever you want. This should be your day.
Oh, that's not the show.
Not necessarily. Here, let me do this. Let me give you guys the answer to that.
Yay.
And then not many. Now, you really have no time to try the practice test. I would almost say it's not even worth to look at this, because then you're just, like I said, you're just agreeing with the work I did. It's almost not going to help you. It's going to make you feel overconfident about, I know that. I feel fine. I'm always warm though, so if I feel fine, it's probably cold. Now, of course, I'll try my hardest not to take it personal if you leave. You can certainly leave if you're ready for the test. I don't want to waste your time. At the same time, if you want to stay, I want to make the most of your time. So I want to definitely go over stuff that we need to go over and try to make more sense out of it. Anything else? Anything we want to move to next? Specifically? Ask it. Okay. Alright, so what are the three, let me go this one at a time. Vertical asymptotes, where do they come from? Let's be careful now. X-intercepts are X-intercepts. They've existed for a long time. Vertical asymptotes must come from somewhere else. And we didn't have them before when we had X-intercepts. So what is a vertical asymptote? It would be like on the thing 1 over x, where is the vertical asymptote? How do I draw 1 over x? How does that look? Yes, it's here and there. Basically, right? Why is there a vertical asymptote here? What x value is that? And what's wrong with 0? Yeah, it can't be. So vertical asymptotes truly are walls that tell my graph where it cannot go. There is one problem at the end of the practice test that deals with an interesting situation where it's not that, but almost, I'll deal with that, don't worry. It's nothing major. But for example, if I had x plus 2 over x minus 1, x plus 4, I have to put walls up where my graph cannot go. It cannot exist over what two x values? Yeah, -4 and 1. So there's my vertical asymptotes. That's actually the equations of my vertical asymptotes. X equal -4, x equal 1. Cool. So the first thing I can do for this problem is set those up. Oh wow, that's ridiculous. Alright, so I've got my wall set up. So immediately I without doing anything else, I kind of can see, well, maybe it's like this, and it does some weird thing in there, and it's like that, or maybe it's down there. It's kind of cut my graph up into 3 regions. Now the other interesting thing now, where do the horizontal asymptotes come from? What are the 3 situations for that could possibly be true about a horizontal asymptote? Either the power. So one situation would be something like x squared plus 1 over x cubed minus 7. The power on the bottom is higher. What's the asymptote in this case? Careful. 0. And the way to remember that is the bottom gets huge. Well, if you're dividing by bigger and bigger and bigger, you're going to smaller and smaller. You're getting to 0. Right? If they're lockstep with each other, if it was like this, they're the same power on the top and the bottom. It's the ratio of the highest. 3/4. I'll have a horizontal wall at y equal 3/4.
So what if the top's higher?
If the top is higher, that's where you get the slant asymptote. Yeah. So if I had like x cubed minus 2x over x squared plus 4x minus 1, officially there's no horizontal asymptote because it's going to go to infinity, but it's going to go to infinity following the dotted line of the result from long division. This is where I'm going to have a slant asymptote. So it's going to go to infinity. It's just going to go to infinity following a line, or possibly even following a parabola if they get freaky. This one, if I did long division on it, I don't have to do too many steps here. X squared goes into x cubed x times. Oops. Yeah, I just need some room for my 0. Let's see, plus 4x squared, minus x, change my signs, -4x squared, minus x, minus 4 here, right? And then I really almost don't care about the rest. The rest is going to be a remainder. You with me? So it's going to have to, in this case, this would follow the x minus 4 line. So as it goes to infinity, it would have to, it could do whatever it wants to over here, it would have to eventually follow that line. Either from up there or from down there. You kind of with me? It goes to infinity, it just has to do it in a specified way. It's got to follow that line. Slant asymptote are obviously one of the freakier ones.
Could you give us a problem when you gave us a graph and then asked us to find
That could be possible. I mean, I could certainly give you a graph that was finished, and I can ask you what are the vertical asymptotes, and you can figure out where they came from. What are the intercepts? You can figure out where that came from. That's possible.
I don't question about the one with the slant. How do you
Yeah.
know, like, 'cause you said it follows the -4 line, right? I mean,
Yeah, the x minus 4.
X minus.
So when you do the long division here, it's x minus 4 plus some remainder here, right? The remainder is going to be over x squared plus 4x, blah, blah, blah. So as x gets really big, this remainder goes to 0.
Yeah, but how do you know how to place your x?
Well, same way we're going to have to figure out where it is in those regions. Is there an x-intercept here? Or is this function here at that point? You know, that's where I have to possibly put a point in or use my intercepts to tell which side it's on.
Where do you put the wall? I'm sorry. How do you know?
There, x minus 4. So when the intercept is -4, the slope is 1.
Also, y minus 4.
Yeah, I'm just graphing x minus 4 as a dotted line. That's all I'm doing. Yeah. I really don't want you to forget this. The horizontal asymptote in this case, which situation am I in for this problem? Which situation is it? First, second, or third? What's the power on the bottom? Yeah, it's x squared. And the top is x, so the bottom power is higher. And in the first situation, my horizontal asymptote is y equals 0. This is an equation. You with me? This is a function. Y equals 0. It's just a very boring one. So what is it over here? Y equals x minus 4. Okay, that's a little more interesting. I just, instead of doing this, I do this.
Yeah.
Not a big deal. I know it involves long division in the middle of all this shit, you know, and that's what makes it kind of weird. But if I could draw a wall like that, why can't I draw a wall like that? So let's finish this one out real quick. So we got vertical asymptotes come from the domain, because they are walls saying you can't go here. Horizontal asymptotes come from one of these three situations. When I let x get really big, what overall will this do? Will it go to 0? Will it approach some number? Will it approach some line? Yes, ma'am. Here? From this example here, right? This is an example of the third situation where the top power is higher than the bottom. And then just long divide. With that problem, no. This is just a quick little side note. Remember the three possible situations, and then I came back and said, well, which one are we in? We're in the first situation. Our top power is lower than the bottom. So we go to 0. Now, this horizontal asymptote comes from letting x do what? I let x do what? Get really, really, really big. So when x is really small, that wall is not really a wall. So the horizontal walls I can pass through. Because when do they come into effect? When x gets really big. As x goes to infinity or negative infinity, y goes to 0. What can it do in the middle? Anything it wants to. In fact, we have one place where it goes through the horizontal wall already. What's the x-intercept? -2. So I'm going to go through that wall. So the vertical ones are you can't exist here. The domain is freaky there. No. Horizontal asymptotes, they really only take effect when x gets really big. So what can happen when x is small? Any damn thing it wants to happen. Right? In the middle, I can go through the damn thing as many times as I want to, as long as eventually I approach it. In fact, to tell you the honest truth, you guys don't want to hear this, I can have a function that just is always going around and around. It's just getting smaller and smaller. So it always is going through. It's just getting, is it getting closer? Yes, because it's not going as far away. It's that oscillation thing, right? So that is still a horizontal asymptote. How often does it go through that? An infinite number of times.
That's trigonometry.
Yeah, it's getting there. Yeah, exactly. This is really like you pluck a guitar string. What happens if you wait? The sound goes away. The vibration's dampened, right? Because of air resistance and the tension in the string and all this other stuff is causing it to stop. That's exactly what it will look like. Whew, so many side notes. So all we have to worry about with the problem is, what's the domain that tells me my vertical asymptotes? What situation am I in here that tells me my horizontal asymptote? So I have one here. And now I look at my intercepts. What's my x-intercept? What's my y-intercept? In this case, I only have one x-intercept, -2, like you guys told me. What's the y-intercept? To find the y-intercept, you make x0. Never forget that. It's always true. Always. So to find it, if you make x0, you get 2 over -4, -1/2. Right? If you make x0, you get 2 over -4, -1/2. Should not be a big deal. So those are anchors. I can plot those points. -2, 0, there. 0, -1/2. I'm not even sure what my scale is going to be here yet, really. How do I figure out what I want my scale to be there? What's interesting about out here? What could it possibly look like out there? Could it look like this? Weehaw! How do I know I cannot do that? There's no x-intercept here. There's no door through that y-axis, right? X-axis. Good job. There's no door through there, so I can't go through there. So it's got to either be like this or like that. And to figure it out, I just need 1 point. Whichever side that output is on, that's where I'm at. Yeah. Yeah. So it can when it's small, it can't when it's big. Or eventually it's got to approach it, right? It can possibly go through it. It's got to approach it. Most of our functions are not going to cross our horizontal asymptotes. Few of them might. In this case, we have one that does in the middle. So back here, what am I going to plug in to see if I'm up here or down there? Yeah, I plug in -5, right? So when I plug in -5, I get, so we go f of -5. It's -3 over -6 times -1. So -1/2. How's that?
Would be in the bottom.
Yeah, so I'm going to be down here. I still don't know what scale is going to be. I don't know. I think we can. This might be safe to make it like this. We'll see. We'll find out. So -1/2 right there. So I'm like this. You guys see how that's determined? 1 point determines that because there's no way through the axis, so I have to be on one side or the other. That's all there is to it. Okay, cool. Now what could be going on in here? What's the multiplicity where that came from? 1. So it's got to go through, doesn't it? So it either looks like this or it looks like that. How are we doing? So plug in, yeah. So it's going to be somehow cubish, right? Let's plug in, because again, can it touch here? The multiplicity it came from was 1. So it's got to go through. It's not going to be a straight line because it's got to eventually come up against this. So it's going to be some kind of a cubish looking dude.
Oh, okay.
I just don't know if it's like this or if it's like this yet. Now where's my y-intercept though? I've already got a point that helps me. I made my scale now like this, right? -1/2. So actually I've got everything I need. So I know it's got to be like this. The less certain you are, the more points you should plug in. Don't plug in like a crazy amount of points, but you could plug in -3 just to see where it is over there. What the hell? Nothing wrong with that. I hate it when I see something like there. You put a point there, but then you never go through it. Like shit, that should tell you something.
From where you get the y is equals 0 in the beginning? Yeah.
Here?
Yeah.
Oh, because we're in the situation where the top power is lower than the bottom power. So the bottom is going to overwhelm the top. The whole thing's going to go to 0. I'm dividing by bigger, bigger, bigger. I go to 0. You got to know these 3 situations here, right? Bottom higher, equal powers, top higher. That's the only 3 possibilities. So the last thing here, what about this side? I can either be up here or down there. Same idea, right? So plug in a point. 2. So what's f of 2? 4 over 1 times 6 2/3. So I am up here. Sweet. So the one time I broke through that horizontal wall was here, and that x, is that very big? No, that's fine. It's just eventually it's got to start approaching it. Not a big deal. So there really are three main things. In fact, two if you really want to put it like that. Asymptotes, intercepts. Other points then help you figure out what side am I possibly on, right? Cool. Asymptotes, intercepts. You can set the framework up. Other points to see where things kind of fall in that framework. Once we do this kind of problem, and then you start looking back at, remember we were doing like x plus 4 to the third times x minus 5. I would think that those kind of problems now seem a little easier, I would think. I don't think there's not nearly as much going on with these things, right? Hopefully. Yeah. Well, you guys could do that kind of problem, right? If I had x minus 1 cubed, x plus 4 squared. What kind of things do you think I would ask about this? Like the very first question I might ask. I love it. What is the end behavior here? Yeah, you can. Yeah, what would the highest power be?
3.
So I might ask this also then, considering. I might say, what will the highest power be if you were to multiply that out? The reason I don't really want to ask that is I know somebody's going to sit there and multiply it out. You don't have that much time. Don't do that to yourself. It would be a fifth power if I did. Don't. So it would be like x to the fifth positive, right? So it would be like that. Yeah, if you did multiply this out, when you get an x to the third power here, as the highest power, plus some other crap, times x squared, x cubed times x squared is x 5. Because any odd power, x cubed, x fifth, is going to look like cube that. It's going to look huge. What would make it go the other way? Negative. If it was negative x to the fifth, then it would of course flip. Of course, like even powers would be this, the positive, or this, if it was like negative x to the fifth. What do you think the next thing I would ask is? Intercept. I love it. You guys like seeing me ask these kind of questions. Intercepts, and when I ask for intercepts, of course, now you guys realize I mean x and y. X intercepts are nice because it's already factored. Yeah, 1, 0, and what about y-intercept?
How do you put 1 into 0? And negative 1.
What makes this 0? What makes it 0? What makes this 0?
Yeah.
Okay, cool. That's it. If it's already factored, I can see what x values are going to make it 0. Yeah. Y-intercept a little bit more work. Yeah, negative 16. Cool. All right. This part of the video is going to be very difficult. Well, you guys stayed.